Okay, today what we're briefly going to talk about is section 2. So in section 2 of chapter 1, we're going to talk a little bit about matter and its properties. So when you say the word matter, we just kind of want to make sure that we understand the difference between a couple other words. So you can see here matter versus mass versus weight. So in chemistry, we're going to tend to use the word terms matter when we're describing a chemical or a compound or something in a reaction. Mass is how we measure the amount of matter, right? The amount of stuff that we have. Really, the word weight we don't necessarily want to use. Weight truly is a measurement that's based upon gravity. So when somebody says weigh out 5 grams, we're really trying to say measure the mass. And so, kind of when we talk about balances and measuring things, mass and weight, again, for us, we're probably kind of talking about the same thing, but we really want to make sure that we do understand the differences. A couple other things here as we work through this section. So we're going to talk about properties and changes. So physical and chemical properties, physical chemical changes. So first of all, when we talk about properties, there's two different types of properties that we want to talk about. Extensive and intensive. So extensive properties are based upon the amount of matter that's present. So the mass of something, if I have 5 grams of salt or I have 10 grams of salt, that mass is an extensive property because 5 versus 10 tells me a specific amount of salt. We could also talk about volume. Volume is another example of an extensive property. Also the amount of energy. If I have a gallon of gasoline versus 10 gallons of gasoline, the amount of energy that will be produced or released from that gasoline, there's going to be more energy with the more gallons of gas, as well as other substances. Methane gas versus butane or propane gas. They have different amounts of energy. Now, intensive properties doesn't matter how much material is present. That could be something as simple as color or texture. In terms of chemistry, we could talk about density. The density of a small piece of iron versus the density of a very large piece of iron. So again, in those cases, intensive properties doesn't matter how much we have because those properties and characteristics are going to be exactly the same. A couple other things to think about physical properties. Remember, a physical property is something that we can use to describe the characteristics, the identity, or the appearance of what we have, what we're looking at. So, physical properties, are they solid, liquid, or gas? What's the temperature? What's the mass? All those different things that we can use to describe what we see. Now, we've got to be careful. Are we talking about, when we see something look a little bit different? Why has that occurred? So whether or not we have, let's talk about water, whether we have H2O as a solid, a liquid, or a gas, we know that we still have the chemical H2O. So its appearance has changed, but a lot of its characteristics and identities have not. Now, have some of the properties changed? Yes, but it is still the exact same chemical. So again, we need to make sure, are we talking about something like, I'll give you another example here, salt, sodium chloride. If we put sodium chloride in water, it dissolves. So its appearance has changed, but we still see the properties and characteristics of those two individual chemicals. If we were to take a drink of that water, we would still taste the salt. We could evaporate the water, and we would still have the salt returning. So again, kind of make sure here when we see something or we make an observation, we'll make sure that we're using the correct terminology for that. Next thing, chemical properties. So here's where we're going to start to see the difference. And I already talked a little bit about salt dissolving water. So a chemical property is a characteristic of a substance and how it reacts, behaves, or changes when it is mixed with other substances. So, sodium chloride dissolves in water. That is a chemical property. Some chemicals don't dissolve in water. Iron does not dissolve in water. So that's technically still a chemical property because we're talking about how they react. Now, if I take a pure piece of sodium, that will react very violently in water. And there's some neat YouTube videos that you can look up at sodium and water, and we'll actually probably do, maybe I'll show one of those in class one of these days. All right. So then a chemical change. So a chemical change is when we have a substance or multiple substances and they react together and they cause those chemicals to change into something new. So we've completely changed the characteristics and identity of the substance. So this reaction right here, actually you've seen probably several times in science class, probably several times in elementary class too, because it's a pretty simple reaction that you can do. So we have this chemical here, it's called sodium bicarbonate or sodium hydrogen carbonate, and this chemical is acetic acid. So we see these are two very different chemicals, but when they react, we get three things: CO2, H2O, and then a chemical called sodium carbonate. Well, H2O we know is a liquid. The sodium carbonate actually dissolves in water. And then we have CO2, carbon dioxide, which is a gas. So you think about this, wait, I mix two chemicals together and I get a gas. Well, what it's going to do is it's going to bubble. So what we really have here, again, mentioned you've probably seen this reaction before, this is baking soda and vinegar. So when we mix baking soda and vinegar together, we got those bubbles that would appear. And sometimes you did it like a volcano experience or experiment. And that's exactly what it is. So again, there's a simple chemical reaction. If I come back here to the sodium and water, when those react, we actually make hydrogen gas. And hydrogen gas can be very explosive. Last couple things here. So again, how do we write these chemical changes? Well, it's what we call a chemical reaction. So you can see here just two examples of chemical reactions that we actually probably will see quite a bit this year. And you might be able to, by looking at a reaction, maybe even make some predictions. Well, how do I know what's going to be made on the right-hand side? Well, if you notice here, you see potassium and calcium are bonded with very specific things, sulfur and oxygen, and then carbon and oxygen. Now, if you notice, the calcium and potassium have traded places. Down here, we see magnesium in a compound and sodium by itself. Now we see sodium in a compound and magnesium by itself. So when we talk about chemical reactions, a lot of times the elements will switch what they're bonding with. Okay, and so when we start to make predictions about chemical reactions throughout the year, it's not something that we've got to memorize all these, unique combinations and different things. There is a kind of a systematic process that we'll go through. The last thing in section 2 that I want to briefly talk about are mixtures. So mixtures is when we have two or more types of matter that are blended together, okay? But they maintain their own individual properties. So salt dissolved in water, good example of a mixture. You could mix some sugar and salt together. That's a mixture. You could mix lots of different things together. The thing to remember is that they still retain their individual unique properties. Now, some of these mixtures could be uniformly mixed, like salt dissolved in water. Some of them are not uniformly mixed. So we have homogeneous mixtures, and then we have heterogeneous. Real simple example of a heterogeneous mixture is a bag of M&Ms. If you were to pull out 5 M&Ms every single time, you're not going to get exactly the same colors. You may pull out and you got a couple greens and no blues. The next time you pull out a couple blues, no greens. So again, heterogeneous is not a uniform mixture. Homogeneous is. And as we go throughout the year, we'll talk more about that. The last thing, a pure substance. So a pure substance is very, very specific. It is only made up of an individual element or a very specific chemical compound. So sodium chloride is not a mixture of sodium and chlorine. It's a compound. Sodium and chlorine have been bonded together. Whereas we get something like salt dissolved in water, that's a mixture. We mix iron and silver together, that's a mixture. So again, a pure substance is a very fixed composition that has very specific characteristics and properties, and they do not alter based upon the combination of elements involved. So as we get into the rest of the chapter, in section 3, what we'll do next is we'll look at a little bit of the periodic table and some things about element names, symbols, and again, some arrangement of how the periodic table is organized.